Hello everyone, hope you're having a wonderful day. So today I want to show you how you can make a system of equation solver in C using Gaussian elimination and then back substitution. Uh, so the first thing we need to do is that we need to set up our matrix. In this case, we'll be working with an augmented matrix that contains both the coefficients and the constants of the system of equations. Let's see how we can input that in the program. So let's see if this works. I'm just going to run the program to see if we can enter the uh, matrix correctly. So run this program. So it says enter the number of unknowns. So let's go through. Okay, what have we done wrong? Oh, sorry. I forgot the main for loop. Sorry for that. Hmm. So after this, you need a for loop to scan for the variables. Okay, so for. Okay, so let's do this again. Okay, so it says enter the number of unknowns. Let's go through again. Enter the augmented matrix. So it's going to be a 3 by 4 matrix. So it's going to have 4 columns. So and it's going to take in the inputs row wise. So the first four elements is going to be the first row, and the next four is going to be the second row. So as you can see here, we have successfully entered the matrix, and now because of the print matrix function, we can just print this matrix anywhere we want. And this function might also be useful to understand the flow of the algorithm a bit better. So after we make the Gaussian elimination function, you can just try and putting this print matrix after each step, and then you can see what the computer is really doing and get a feel for it. So uh, this is the main part of the program, which is Gaussian elimination, and we're just going to do two main steps. We swap the rows if the diagonal element is smaller than the one below it, making sure that the largest number of column is in the pivot position, which is basically the diagonal of the matrix. So what is the diagonal of this matrix? It's going to be 12, 12, and 23. So it's not really correctly set up here because what is the first element of this matrix, right? 1, 1, sorry, 0, 0. It's 12, and it is the biggest first element. But 12 is not the biggest 2, 2 element we can have. So the computer would just swap row 3 and 2. So 88 would be in the position of 12, and 56 is going to be in the position of 23. So that is going to be quite helpful in our calculations. So let's get going. So the first part is pivoting, and the next part is elimination. I'm just going to explain what that is later. Okay. Wait, Okay, so we're done here. So what this thing is doing is that it's comparing matrix II, which is going to be the diagonal element. So you can think of it like this. So every diagonal element is going to have the same index. So that means uh, for 12, it's 0, 0. For this 12, it's 1, 1. And for this 12, it's 2, 2. So we're just going to compare the diagonals. And the first part of the logic is that, okay, if we find out that this element 12 is smaller than 9, which is it's not, then we're going to first swap uh, this row with this one. So we make a temporary variable to store what the matrix ij was, and then we make matrix ij equal matrix kj, and kj um, is the element right below this one. So then you swap the positions just like this, and now we come to the main part, which is back substitution. No, sorry, not really back substitution. Gaussian elimination. We do back substitution later. So what we're doing basically is that we're trying to find a factor to multiply the row before that. So after we sorted this out using this part over here, so after pivoting, we first try to figure out that, okay, there's a 9 there. How can I make it 0? So what we can first do is that we're going to divide the first diagonal with 12. So this is going to be 1. And 9 times 1 is going to be 9. So after that, so if we multiply 12 with 9 divided by 12 is going to be 9. And if we subtract the row 1 from row 2 is going to make this element into a 0. And don't worry about the other elements because that really doesn't matter. And for the next row, we also do the same. We first make the 3 equal to a 0, and then we're going to turn this 88 into a 0 using this one over here, this second row over here, where the second entry is 12. So we're going to somehow turn 12 into 88 and then subtract it. And we're just doing this over and over again. So that's why you see a bunch of for loops here. Um, Try using printf statements to see what is really happening here because it might take some time to get used to this. A lot of complications. I had trouble the first time understanding this. I guess you'll probably have too. So let's go ahead. Okay, so we're done here. Now what we're doing is that we found this scaled factor, and I'm just going to use this print matrix function to show you that it works. So after we're done with this, so after each of the swapping, I'm just putting this print matrix function over here. So um, print print matrix. And don't need to declare anything. So it takes matrix as an input and n as an input. Okay, and we're going to do the same here. Copy. And now we're going to call this void Gaussian elimination function here after this. So don't need to declare it again. Okay, let's run this program. Just going to clear this. Okay, I probably should have made a bunch of printf statements. I made a space too, so that it's not that cramped. Printf machine. Sorry for this. So after each step, we just print a new line so that it doesn't get cramped. I'll have to run it again. Sorry for that. Okay, so as you can see here, okay, I should have added a new line here too, but I guess this works. But um, as you can see here, it doesn't work at all. It's not really making things into 0. What is the problem?